Today, we're going to explore the fascinating world of biohybrid robots and how scientists are using machine learning to make them even better. Imagine, if you will, miniature robotic rays powered by actual heart muscle cells. Sounds like something out of science fiction, right? But it's real. And it's happening at Harvard University. Now, for years, scientists have been trying to build robots inspired by nature. This is called biomimetic design. Think of it like trying to build a plane by copying a bird's wing. It's a good starting point, but it has its limitations. Let's take our robotic rays, for example. There are so many different types of rays in the ocean, with different fin shapes and sizes. Which one should we copy? And just copying a ray might not be the most efficient way to build a robot. We need to consider the physics of how these creatures move through the water. This is where the clever folks at Harvard and NTT Research came in. They asked a really important question. How can we design the best fins for our biohybrid rays, considering the different environments they might operate in, while also respecting the natural laws of how swimming creatures work? They realized that just copying nature wasn't enough. They needed a smarter approach. So what did they do? They turned to machine learning. Now, machine learning is like teaching a computer to learn from data, just like you learn from your textbooks. In this case, they used machine learning to explore a huge number of different fin designs. It's like having a super fast, super smart assistant that can test thousands of different options in a very short time. Think of it like this. Imagine you're trying to find the perfect recipe for a cake. You could try random combinations of ingredients, but that would take forever. Machine learning is like having a chef who can quickly test different recipes and tell you which ones are most likely to be delicious. The researchers developed an algorithm to create many different fin shapes. Then, they used machine learning to search through these designs and find the ones that would allow the rays to swim the fastest and most efficiently. They called this process machine learning directed optimization, or MLDO for short. And guess what? It worked. The machine learning system helped them discover a fin design that was much better than anything they could have come up with just by copying nature. These new fins had a large wingspan and tapered tips, which turned out to be incredibly efficient for swimming. Using these new designs, the researchers built tiny biohybrid rays, about 10 millimeters wide, made of heart muscle cells and rubber. These little rays could swim on their own, and they were twice as efficient as previous designs. That's a huge improvement. Now, while these biohybrid rays are amazing, the researchers are still working on making them even better. They're not quite as efficient as real rays in the ocean, but they're getting closer. What's really exciting about this research is that it shows how powerful machine learning can be in the field of biohybrid robotics. By combining biology and engineering with the power of computers, scientists are creating incredible new technologies that could have all sorts of applications in the future. Imagine tiny robots delivering medicine inside the body, or exploring dangerous environments. This research also helps us understand how nature itself designs things. By using machine learning to explore different designs, we can learn more about why certain shapes and structures are so effective in the natural world. So, class, remember, biomimicry is a great starting point, but sometimes we need to think outside the box, or, in this case, outside the fish. By using the power of machine learning, we can create biohybrid robots that are even better than anything nature has come up with on its own. If you love discussions like this, don't forget to like, comment, and subscribe so you won't miss more awesome videos. See you in the next science exploration.